All right, good morning, cats and kittens. My name is Aji. My pronouns are they, them. And I work at a place called Thoughtbot. So I usually tell a little silly fact about myself at the top of my talks, but this time I'm going to be a little more real about it because I'm still new to this Hotwire stuff. I was up late rewriting this talk all last week because I had a Hotwire suggestion while pairing, and the response I got was, "Oh, honey, no." My pair didn't say that, but that's how I heard it as they linked me documentation about just how wrong I was. But also something clicked, right? And I got a little further along in my understanding than I was before. And if only my anxiety would learn that embarrassment at work usually leads to being so much smarter afterwards, I could look forward to it instead of like this. I feel like I'm having a harder time wrapping my head around this than everybody around me. I think it's because I'm so hardwired to think in React. Every moment where I've taken a leap in my skills with this whole Hotwire thing has been because another one of the thought patterns that served me so well in React land has fallen away. I tell you that because I'm trying to save a few people who are making a similar change in their day-to-day tooling or code bases, save them a little bit of that cringe, a little bit of that, "Oh, honey, no." I already did it, so you don't need to do it too. But like many of us, if not all of us here, I identify as a Rails developer. Ruby is the first programming language I truly learned. I do not count BASIC from back when I was 12. But like many in the Rails world, I have spent the last few years using Rails not as a full stack application framework, but in API mode, sending JSON over the wire to various versions of a React front end. Hotwire, React. I'm not going to say that one is better than the other. I'm barely, if at all, going to spend time highlighting strengths and weaknesses or talk about trade-offs. This talk isn't to convince you to switch. We all know that it's trade-offs all the way down, and the frustrating answer to every question is, it depends. The moment in question today is beyond that decision anyway. The application you're building or are about to build is or will be written without React, using nothing but Rails, Hotwire, Turbo, Stimulus. Maybe Turbo native, but that's a different talk. If you've written a lot of React lately and are new to this Hotwire world, if you think in components and hooks rather than turbo frames and stimulus controllers, you are where I was 6 months ago, and you are who I'm here for. And if you already know a little bit about Hotwire, just don't heckle me during the entry-level stuff, okay? If you're unfamiliar with the players, let me introduce you before we get too far along. Hotwire is, as of Rails 7 in 2021, the framework's built-in solution for the front end, and it's made up of two, for now, parts, Turbo and Stimulus. Turbo is the successor to Turbo Links. It accelerates links and form submissions by capturing interactions and submitting via JavaScript, allowing for partial updates and independent loading of portions of the page. Stimulus is a system that allows for graceful interaction between narrowly scoped JavaScript controllers and our HTML, for those interactions that need to exist completely on the client side. And before 6 months ago, these were not in my wheelhouse. Okay, I love React. I know that is a weird thing to say at RailsConf, but I really do. Like Eileen and Rails, it just fits with how my brain works. The declarative UI runtime reacting to changes in the state of a system made of component trees with data down and actions up. And sure, it's produced by a shady mega corporation. But it's not like it's the only place in tech where we love a technology despite its founder. On top of React, let's add in GraphQL, which I also stan. And even our much beloved backend starts to look less and less like Rails with essentially no controllers and only a single endpoint. And even though my current situation leads me to write a talk about how to use Hotwire and leave React, I'm pretty sure I still have more fun writing React. It just fits with how I conceptualize the front end and complex UIs, which is what made the transition from my current project particularly difficult. This project is a greenfield application. Lots of interactivity with the user, including chat and real-time updates to information, that real SPA kind of feel. Well, what is SPA anyway? Webster's dictionary defines it as a commercial establishment providing facilities devoted especially to health, beauty, and relaxation. But my client is in health insurance, so none of that's covered. Well, when we talked about SPA, it meant single page application. It's such a broad term, it can mean anything from the literal web app implementation that loads from a single web document and then updates the body content of that document via JavaScript. That is from MDN. To describing the experience that users have come to expect, like this: a fast, responsive, and interactive web application that provides a smooth and engaging user experience with real-time updates, mobile responsiveness, and fluid interactivity. This one is from me and ChatGPT. It's like a 50-50 collab. So giddy at the opportunity to not pull in a front-end framework, both my team and my clients were excited, confident that Hotwire would bring that SPA browser feel. And despite my fondness for React, I was excited too. Server-rendered HTML, just like Mom used to make. It's an idyllic return to the first principles of the web. Hotwire sounded analog and peaceful after years of JavaScript loading up on new features like toilet paper in 2020. What I didn't appreciate at the time was how different the problem-solving techniques and patterns were truly going to be. So we're getting to the heart of my motivation for being up here with you. A mental model is an explanation of someone's thought process about how something works in the real world. So I want us all to think of the solar system. So do it. Think of the solar system. You probably conjured up something like this, right? This picture of planets orbiting the sun probably reflects the mental model of most, because this representation is good enough for our day-to-day interactions with Jupiter. The representation we carry will influence how we approach problems. An incorrect mental model led Senator Ted Stevens to claim that streaming video had clogged the internet's series of tubes, causing his emails to arrive days late. For us, here in this room, the wrong mental model can leave bugs in places we would never even think to investigate. And although React and Hotwire are solving the same sorts of problems, the metaphors, concepts, and building blocks that make up the tools we'll use to solve those problems aren't really compatible. And I wasn't going to Ted Stevens my way through this project forever. So I'm going to describe my mental model of working with React. And I bet it's pretty close to how many of us think in that system. It's a tree of components. The rendering of this tree starts at the root. That's usually app or something similar. Each component along the tree has the ability to render DOM elements, nothing, or more components. And the components deal in data, manipulating it or passing it to child components as props. Data can only flow down the tree from parent to child. Data flow is fundamental as a React developer, and it gives us one half of that React mantra: data down. In this model, as we're looking at it here, network requests are irrelevant. I bring this up because trying to equate them between this model and Hotwire will only be confusing. Okay, but it's web dev, right? Like, how can network calls be irrelevant? Let's focus on this component here for a moment. This component gets some props, uses this data in a function to derive new state, and uses that state to conditionally render children. Now let's say that this component gets some props, uses this data in a network request that gives it new state, which it uses to conditionally render children. They're functionally equivalent. So there's nothing that you can do from elsewhere in the tree to determine if that change was local, a hook, user input over the wire, or even just hard-coded. So for our purposes today, forget that React makes network calls, and don't try to find an equivalency with Rails. The one last piece to this model is callbacks. As well as with data, a component can send a function down the tree, which can later be invoked by a child component, and that is the only way to return data back up the tree to components higher in the order. And that's where we get the second half of that React developer mantra: actions up. So those are our building blocks of a React application, the components and the state, data, and the actor in this system is the data. State drives us forward. A change in state causes a reaction in the component tree, and we can think about how to move state around the tree by remembering data down, actions up. So this was the model that I had been working with for years. The solutions came easy to me. The solution that came easily to me started with trees and state. But Hotwire was impenetrable until I could leave the old problem-solving models behind. All right, conference talks I find are not particularly great for picking up on syntax and specific technical details, so unless you're watching this virtually from the future, in that case, hello! Rails greater than 7 is pretty great, isn't it? I'm going to get through as many examples as I can, and I encourage you to be present, follow along, pick up the concepts and the mental models without trying to read every line of code. For the rest of it, I've got some resources at the end, and I'll invite you to keep an eye on the Thoughtbot blog for write-ups of these examples in more detail throughout the coming weeks, including a couple that I couldn't get to for time. All right, I'm going to take us through building and then enhancing a site with Hotwire. What site? The Ruby on Rails guides. I hear you out there. Yeah, I do. Saying, Aji, is this a plug for your new podcast, The Tightly Coupled Book Club, where you and your equally charming and vastly more intelligent wife, Mina, and fellow Rails developer read the Rails guides cover to cover and discuss it like a book club? First of all, how dare you? That is a baseless accusation that is so obviously true, I am not going to dignify it with a response other than please follow us in your podcatcher of choice, rate and review us on iTunes, and buy a Casper mattress. Upon arrival at the guides, we're greeted with these links, which each open their own page. Therefore, we will refer to these as pages. Within a page, there are chapters. Within chapters, there are paragraphs. And that's where we'll start, with pages that have many chapters and chapters that have many paragraphs. And the structure of our exploration will be mostly to the tune of if that in React. Think this in Hotwire. I say mostly because the first thing I want to do is immediately not do that at all. There is a mindset difference in approaching assembling a site with Hotwire, and it is this. Start as if you didn't have Hotwire at all. If we follow Rails conventions, we'll be able to use Turbo to enhance the experience by adding only a few lines of code and little, if any, JavaScript. This was probably the biggest hurdle for me. Thinking that the document would be partitioned off and calling for new components instead of simply requesting a page. Let's start with these 3 routes, and we'll take a look at the mockups. First is pages index. This is going to be the layout that we're working in, a Rails red header up at the top, the pages list on the side, and because the user hasn't chosen a chapter yet, we have nothing to load, so why not go for some Rails nostalgia? And here's pages show. Same header, chapter placeholder, but the page list is expanded for the selected page, and we can see the chapter titles. And last is chapters show. And maybe we saw this coming, but it's going to show the chapter. So I've set up a partial that will help us deliver the 3-part layout that we see here. We'll call it navigation frame. So it holds the header, which doesn't really change, and these yield calls that here are named in order to be able to target the specific locations of them later. If you're thinking about putting this in a layout, hold on to that thought. So we're going to go to the chapter show template to get a feel where we're going to be spending a lot of our time. These 2 content for calls matched up with the named yield regions we saw before. They're holding all the content for those portions of the page, and that content is in these 2 partials. We'll open them up when they become relevant for our examples. But let's take a look at what the site looks like from here. Pretty good. So far, the navigation frame is holding up the layout, and those partials iterate the content, pages, and chapters on the left, and chapters plus paragraphs on the right. One of the building blocks of Turbo is the Turbo frame. It's described pretty often as being scoped navigation. So look at the chapter region of the layout. If that box was a turbo frame, interactions inside it will, by default, only affect what's inside the frame. So what is the React equivalent of scoped navigation? In React, scoped navigation kind of doesn't make sense. You follow along the rendering path and you get to the end here, there just is no direct link to here. Navigation is already scoped. It's not the Wild West like a web page. Navigate wherever the anchor tag takes it. We're hardwired to know that the only way to that other component is back up and over. So what even is a frame in this context? It's a router. From the layout, I see two candidates for turbo frames. The left that switches between pages index and pages show, and the right which shows a single chapter at a time. We'll stick to the chapters template, but know that we'll need to put this frame in the same place on all three: pages index, pages show, and here in chapter show. We want the turbo frame to wrap everything that should update when a link inside itself is clicked. That's the whole chapter region, so we'll make it the topmost element in that block. Rails provides a turbo frame tag helper. This renders out to a custom element of, you guessed it, turbo frame, and you see there it makes the first argument an ID. That's actually it. That's all you have to do. What does this look like in the browser? That is a different video, I promise. We'll be able to see the difference if we take a look at what HTML is actually being sent over the wire. So this is the HTML delivered by the server when we first visit chapter/1, and I certainly do not expect anyone to be able to read this. I'll take you through it. These lines here are the head tag, JavaScript, CSRF meta tags, page title, style sheets, nothing out of the ordinary. The body tag here starts with that Rails red header that we've been working with. And here's the page region. There is a selected page with 3 open chapters currently. And this is that first selected chapter with all of its paragraphs intact. That is all of the markup of our page, from Rails' head tag, our layouts, pages, and chapter. And right here at line 66 is our turbo frame even. So far it's as expected. But what about when we click that link from inside the frame? That next chapter link. All right, the second chapter can't be that much shorter, right? So there's the chapter. There's the page list. There's that header. And that's the head tag. It's empty. When Turbo intercepts the clicks, sends the request via JavaScript, includes a special header, turbo frame and the frame's ID. That way the server knows that the page it's talking to is turbo enabled. It already has the contents of the head tag and doesn't bother sending it. You know what else it doesn't send? The layout. So we didn't put the navigation frame code there, and the turbo frame can't be there either, and this is why. So we'll take a little peek into that Hotwire mental model. We make our first request and receive chapters 1. Remember, this section of the page is encased in a turbo frame with the ID chapters. When we click the next chapter link, Turbo sends a request for chapters 2, and down it comes. It's essentially the whole page, minus the head tag. Turbo is going to inspect this response and look for a turbo frame element that matches the one it asked for of chapters. And if it finds it, Turbo will punch out the old chapters frame and throw it away. It will remove the new chapters turbo frame, throw away the rest of the response, and switch the new frame in, having only updated the part that needed to change. Sounds kind of React-y, right? React won't update parts of its component tree, and therefore the DOM when data dependencies haven't changed. Neither here will Turbo update the DOM if it hasn't been directed to. All right, let's jump into another example. Let's apply a turbo frame to the pages region. Just as we wrapped chapters region in a turbo frame, let's do the same with the pages. Same thing, we're ready to go. It's pretty great to be able to take advantage of this functionality with so little code. So let's see how this improves the experience in the browser. Okay, clearly we have broken something. If we think about the interaction that Turbo is having with the response, it should become clear. After clicking that link, it's gotten rid of the old pages frame and replaced it with the new one. But if the left sidebar is scoped to that frame and the chapters were never in that frame, but this is a pretty common use case, right? You click on a link in the header or sidebar of a web page and the main section changes. So in React, we find ourselves needing to reach another branch of the tree. We know that it's going to have to go through the closest mutual parent component, and that parent component will send a callback down one side and then send props across and down the other. So think this in Hotwire. So we're on the page partial. It's not the show or index template, it's the models partial, where we iterate the chapters into links, iterate them into existence. We can tell this link which frame we want it to swap out by adding a data attribute to the anchor tag. Turbo frame tells Turbo to target the chapters frame from the response instead of the frame which originated this request. Turbo action we've added so the URL will update to the address of this link. That way our users can bookmark specific chapters and come right back later. Let's see the chapters controller. So we've had this query for page.all sitting here this whole time. If we peek at the top of the chapter show template, we are rendering that page index, and it needs the data somehow. Even so, I don't particularly love that this page data getting mixed up in our chapters controller. And as you might expect, there is a Turbo answer here. We'll start by taking out the offending database query and moving over to the chapter show template. And we'll get rid of the page list partial. It's why we needed that query, so bye-bye. And we're again going to add an option, this time to the Turbo frame. The source attribute tells the frame to begin turbo navigating as soon as it's loaded into the DOM. So in a React component version of what we're trying to accomplish, a useEffect hook makes a network request and places the response in this component state. The empty dependency array tells us it's going to do that just once on mount. And if we don't yet have data for the pages, we'll render a loading message. And once we have it, we'll render the page index. It's a pretty common pattern in the React world to eager load some data as soon as the component is activated, display a loading message for the user. So when the page loads, Turbo will notice the URL and fire off that request. But the React version was able to handle a loading state as well, right? Well, the block inside the Turbo frame will be rendered in the same manner as before. It'll be replaced, though, as soon as the response comes back. So let's take a look at this live, and I'm going to artificially slow the server's response so that we can actually see the loading state. Great, fixed it. The most exciting thing about this here for me, though, is that each of the clicks on the chapters on the left are also visiting the chapters show action, which, if it were a full page reload, would hit that slow query all over again. But the navigation is contained to our Turbo frame on the right. Everything stays snappy. Here at the newly revamped Rails guides, we want to make contributing to Rails easier than ever before. So in that spirit, we are announcing live inline editing of every paragraph on the guides, because there's no way that this could go poorly. I feel like this is a wheel I've either reinvented or seen reinvented several times across the React products that I've worked on. We need to be able to toggle between read mode and edit mode inline and have live updates on save. Given the ease of conditional rendering in React, having a component that toggles between two children is actually pretty straightforward. We'll need some local state to handle the state of the conditional. We can pass in two components, one for each view and edit, and each of them can handle their own manner of viewing, editing, persisting, however they like. The view edit wrapper can very easily be separate from any of that logic. It's even pretty trivial to be resource agnostic from this component's point of view. And we send down a callback to handle the toggle for each of the components to implement however they see fit. Button, keyboard shortcut, timeout, whatever. So we'll start by looking at the paragraph controller. And this is a standard off-the-shelf Rails controller that very well could have come with Rails G scaffold. It only has edit and update because we're going to leverage some of our other infrastructure otherwise. And we can see some of that at play here. We won't get into some of the nifty things Turbo can do with forms today, but instead we're going to render the paragraphs chapter, which contains all its markup. And I've taken the liberty of adding the necessary routes as well. So we'll visit our chapters partial. This is the only place that we've been rendering the paragraphs so far, right here. The content is going straight into the cram down gem to take the plain text from our database and turn it into markup in HTML, markdown in HTML. Let's extract a component, partial, for our paragraphs. Okay, we're off to the races. Take a look at that. Cool, so this is really all that we've ever had for the paragraph so far, but we're going to start out with our new friend and wrap this in a turbo frame. We've got a little something new this time around, though. DOM ID is a helper method that Rails gives us to make identifiers from objects. Mashes up their name and their database ID, as well as optional arguments. It's a shortcut for creating a meaningful ID attribute for your turbo frames. If this one was passed a paragraph with ID 1, it would generate this, easy peasy. Some quick styling considerations, and here we are. A link to the RESTful edit route associated with this resource. A Rails link to, Rails URL helper. The closer we stick to convention, the easier this is going to be to fit together. And this is the most specific and kind of tightly narrow turbo frame that we've tried yet. Let's look at the edit template. It's a blank slate so far. It's almost a shame to fill it with the least surprising form possible. Oh well. Can't forget the turbo frame tag. Remember, we've got that narrowly focused one around the link that gets us here. So let's take a look. Nice. So look at that. Frame scope to an instance-specific identifier can be mighty powerful indeed. And we've done our part to ruin the brand new Rails guides. There is one thing to point out. We did it because of limited time and space, but our other view templates, pages index, chapters show, etc., had all of the places for putting together the entire page. The paragraph edit did not. It did have the turbo frame that we needed, so its limited markup did the job, but what would that route look like without the rest of the site already loaded and turbo spun up? Not the best UX, is it? All right, so keep that in mind as you're building out these sites. All right, let's do something fun. It's all been fun, but funner. So we've been focusing so much on Turbo, we haven't talked at all about Stimulus. This is Hotwire's client-side JavaScript component. So often, Hotwire opens possibilities without more JavaScript, but there are some behaviors that have to take place completely on the client side, like keyboard shortcuts. We're going to add a modal chapter search that can be triggered by hotkey. Keeping in mind React's power when it comes to conditional rendering based on a Boolean switch, let's focus on the keyboard shortcut. We've got a use effect that starts us off by setting some vanilla JavaScript event listeners, and we'll be waiting to hear a key down event. We'll return a cleanup function to make sure the listener is cleared if this component unmounts, and here's the key down callback. We'll inspect the event for the key combinations we care about and update the state. Now we are going to open up the layouts application template. Since our attributes that define the interaction with key events are application-wide, we'll put it on the highest component, straight on the body tag. Stimulus connects to the environment through the DOM via these attributes. The first one we'll add being the name of the controller we want to connect to this element. Data action defines the event handlers, and the key down event is filterable by key press. So these two lines here are actually all that's needed to set both meta-k and escape hotkey handlers. The right side of the arrow in these expressions denotes the controller and function we want those events to trigger, the same controller, hash, method, convention that you see in the routes file or Ruby API docs. Now, following convention over configuration in true Rails style, the file name matches to the data controller value in the body tag, making this controller wake up and pay attention. The toggle function manages a CSS class on the modal, so we'll hide it or show it. And these target definitions, those array of strings, map behaviors to elements on the page that we'll identify in the HTML, and stimulus does the DOM scanning for us. Back to the navigation frame. So half of this file that we've seen before, I'll get a little closer to the new stuff. The modal, starting hidden, wraps a Rails form with a single text input and a few stimulus-specific data attributes. Those are the attributes that identify the elements to the controller for use in the functions that we saw, those targets. Data, controller name, target, and the identifying string. It'll submit with a GET request to a new route, and the response will be scoped to an empty turbo frame. That is the target of our form. Without it, the response would have no frame to replace into, and it would take over the entire page. So in the chapter search controller, Okay, so chapter search controller, we're going to perform a fairly naive search through an SQL ILike wildcard implementation, which in turn renders this view. Which iterates the matched chapters, linking to each. And if we look here, there is a target option with the name of _top. This is new. We don't want the resulting links to try and be scoped into the search results frame. Rather, _top tells the page to perform a full navigation to the show path of the chapter in the link. Let's see what we've got. There you go. Cool, that's actually the last example that I could squeeze into this thing, so I know it's a little abrupt, but thanks.